So just thought about this question on the other day. Can a circle and a rectangle have the same perimeter and the same area? What do you think? If you say the answer is yes, then no, you are not correct. But if you say the answer is no, then yes, you are correct. Let's first talk about this right here. Let's say we have a rectangle with dimensions x and y like so. Then the perimeter is just 2x plus 2y, and the area is just x times y. So this will be the labelings and also the variables that we're using. And then the circle with radius r. The perimeter is the same as the circumference, which is 2 pi r, and the area is just pi r squared. So far, so good. Now, putting things together, we first want the perimeters to equal, so I must have the condition that 2x plus 2y being equal to 2 pi r. Next, we want the areas to be equal, so xy is equal to pi r squared. Now, this right here looks very intimidating because besides the 2, we have like 4 letters, x, y, and pi and r. But pi is not a variable. It's about 3.14. So how do we even approach this, right? Well, first, I'm just going to divide the first equation by 2. And let me subtract x to both sides. So we get y equals pi r minus x. And then put this into here. And then we can get x times pi r minus x. And then that's equal to pi r squared. Okay, and then let's try to see if we can reduce to something that makes more sense. Perhaps let's just distribute the x. So we have x pi r minus x squared, and then this is equal to pi r squared. And depending on how you want to solve it, if you want to solve for x, that's a quadratic equation. If you want to solve for r, that's also a quadratic equation. So you're like at a lose-lose situation. I'm going to try to solve for x. Anyways, though, doesn't quite matter. Put this to the other side, so we get positive x squared. And then put this to the other side, that's minus, I will write down pi r first, and then x. And then this is plus pi r squared, and that's equal to 0. I'm looking at this as a quadratic equation in terms of x. So let's use the quadratic formula. X will be equal to negative b, which is negative pi r, and then plus or minus square root of b squared, which is negative pi r, and then square that, minus 4ac, a is 1, and c is pi r squared, all over 2 times a. Okay, and we have to be careful because we have a square root. So what that means is that we have to make sure instead of the square root cannot be negative, because otherwise we will have to go to the complex world. Okay, so we have to focus on this part right here. We wanted to make sure that is non-negative. And now let's just work this out. Here we get positive pi squared r squared, and then that's minus 4 and then pi r squared. And we want this to be non-negative. So if you factor out pi and r squared, and then we will end up with one more pi right here, and then minus 4, and we want this inequality to be greater or equal to 0. Now here's the deal. R squared multiply with this and that, right? In fact, I can divide both sides by r squared. Because imagine if r is equal to 0, then we don't have a circle, we have a point. That is not what we are looking for. Moreover, if r is equal to 0, then you can go back and say x is 0 and y is also 0, which it's not what we are talking about. So right here, I want to add a condition that r should be greater than 0 to make sense. So right here, notice that since r is not equal to 0, so I can divide both sides by r squared. And of course, pi is not equal to 0, so we can also get rid of that. Yeah, so get rid of this, all that stuff. Yeah, plus put pi right here. Anyways, though, if you look at this part right here, we end up with pi minus 4 is greater than or equal to 0, so that's pi is greater than or equal to 4. Wow, look at that! Pi is greater than or equal to 4. How is this even possible? It's not. Well, maybe it is, I don't know. So this is false. What that means is that this question right here is not possible. Okay? And in fact, besides doing the algebra, you could have argued it by the following way. Here's the idea. If you have any parameter, so I'll say given parameter p, I will tell you though, the fact is that a circle has the biggest area among any other shapes that you can enclose. So no matter how you're trying to enclose your rectangles or square or triangles, whatnot, these will never be the same as that. So even though this and that have the same parameter, but they can never have the same area.